Section 1.4, relationships and patterns. Everybody knows that when you have a consistent pattern with numbers, or as we've talked about, and most people should know now, as we use patterns, numbers are consistent throughout a pattern. If you looked at term 1, 2, 3, and 4 here, there's a consistent pattern across each one. And you can see that term 1 has 3 boxes, term 2 has 6, term 3 has 9, term 4 has 12. Each one, if you hadn't noticed already, is going up by 3 boxes each time. The term number would be what we could possibly replace with a variable if we didn't know. If we were to start with this section here and use this term to start, we wouldn't know where that fell in a pattern. We would just see that it was n and that they would be related to n in terms of 3. So the term numbers 1, 2, 3, and 4. Term 1 here has a term of 3. Term 2 has a term of 6. Term 3, the term number 3, has a term of 9. Term number 4 has a term of 12. Each term, its relationship to the number of boxes is it's being multiplied by 3. So term 1, you could look at it as 3n. That is the relation for all of these patterns. Every term number would have a different number of boxes. If I got down to the end here and put in term 5, I could replace the n with 5, and I would have 15 boxes, and the pattern would continue to carry on from there. If you look over here, this chart helps us to show how the term relates to the term number. In this case, the term number is related to the term in the relation 3n, or the term number is multiplied by 3. All expressions are relations. That's basically what it is. And all relations are shown, you can show through patterns. Again, back here, the expression is 3n, 3 times a number. And depending on which number it would be here, you can see up here in the boxes, if it was term number 1, the relationship of 3n would be 3 boxes for 1. The second one, if you put it into the relation, term 2 would give 6 boxes. If you put term 3 into the relation, 3 times n, or 3 times 3, would give you 9 boxes. 3n, or 3 times 4, if you put term 4 in, would give you 12 boxes. An example of that over here is going from a chart and to try to understand what the relation would be. The term is related to the term number. Whatever happens to the term number will happen to the term as well in that relation. So looking here, based on what we have for term numbers and what we've been given as for terms, what is the relation between the term number and the term? Well, if you look at the first one, 1 is the term number and the term is 3. 2 and 4, 3 and 5. If you go all the way down this, you can note it all the way down the term number line, you'll notice that they're related n plus 2, n plus 2, n plus 2. The relation here is n plus 2. If 4 is my n, the term number represents n, 4 would go in over here for my n. 4 plus 2 is 6. 5 plus 2 is 7. 6 plus 2 is 8. My term number is my n. The relation that goes from my term number to my term would be n plus 2. My term number plus 2. The second set here, if you look at my term numbers 1 to 6, they all have a term that goes in relation to that term number. 1 in relation to the term is 8. 2, 16. 3, 24. 4, 32. And you could think, okay, well, 1 plus 7 is 8. But 2 plus 7 isn't 16. You could think, well, it might be times 4 and then plus 4. 4 times 1 is 4, plus 4 is 8. But 2 times 4 is 8, plus 4 is 12, so that doesn't work out. If you look at it, these term numbers are going up by 8 for each time this goes up by 1. So you can figure out that the relation is 8n. Every time you have a term number, it's multiplied by 8. So 1 times 8 is 8. 2 times 8 is 16. If you switch the n for a 3, 3 times 8 is 24. 4 times 8 is 32, and so on down the pattern. I could give you any term number, and using this relation, you could figure out what the term would be. If the term number was 10, it would be 8 times 10, and your term would be 80. You're basically coming up with a pattern rule. You did it in grade 6. You're basically deciding what is happening to the term number to make it into the term. In this case, it was you're adding 2 to the term number. In this case, you're multiplying it by 8. So what your practice is going to be today, it's just a two-parter. N is equal to the number of students. So what would be the relation of the total number of pencils if each student has 3? So there are N number of students. It doesn't matter how many students you have. Every single one of them has 3. So what would be the relation of the number of pencils to the number of students? How could you figure that out without ever knowing? How you could write a relation without actually knowing how many pencils there are? What would be the relation for the total number of pencils if each student has 3 and N is equal to the number of students? Once you've written that relation, you go down to B, and you've been given a chart, term numbers 1 to 6. You have to find out the relation for the situation that the number of stickers, if each student gets 4 stickers and there are 10 left over, what would be the relation to go with the term number? Each student gets 4 stickers and there are 10 left over. So if one student got 4 stickers and there were 10 left over, how many would there be? If there were 2 students and they each got 4 and then there were 10 left over, how many would there be total? If there were 3 students and they each got 4 stickers and then there were still 10 left over, what would the term be? If the term number is 4, if each student gets 4 stickers and there are 10 left over, what would the term be? 5 students, they each get 4 stickers and there are 10 left over. So for the first one, for A, you're just writing a relation. For B, you're writing a relation for this sentence and filling out this chart.